Consecutive interior angles have to be on the same side of the transversal between the lines. So angle 8 and angle 3, or angle 3, angle 8 and angle 7. Another pair would be angle 3 and angle 4. Corresponding would be angle 1 and angle 7, angle 8 and angle 6, angle 2 and angle 4, and then angle 3 and angle 5. What's the relationship between angle 3 and angle 7? One's on the left, one's on the right, one's above the line, one's below the line, so they are alternate interior angles. Which statement is true? So FEG, and CBE. It says they're alternate exterior. Well, they definitely aren't. CBE, so that one, and DEB, so DEB are alternate interior. No, those are consecutive interior. CBE and DEB are consecutive interior, and there's the one that is true. Number 5, non-adjacent angles formed by intersecting lines are vertical. Adjacent angles whose non-shared sides are opposite rays are a linear pair. And angles that have a common vertex and ray when no common interior points are adjacent. Name the angle supplementary to COD. So you have a couple of options. You could have done DOE, or you could have also done angle COA. Just name an angle complementary to COD. So complementary would mean they'd add to 180 some of the measures, so that would be angle BOC. Name a vertical angle to DOC, that would be AOE. Name the sides of BOC are going to be OB and OC. Name a point on the interior of BOE. So that would be, well, what point is on the inside of this angle? It would be point A. Okay, number 7 says name the transversal that forms each pair of angles. So when we talk about 2 and 12, well, that would be A. And identify the special name. Those are going to be alternate interior. So 6 and 18, transversal is D because they're both on D, and those are corresponding. Next one, 13 and 19. Okay, transversal is B. They are on the outside of the lines and on opposites of the transversal, so they're going to be alternate exterior. 11 and 7, transversal is C. Those are consecutive interior. Okay, 2 and 13 actually have no relationship. Okay, so it's just no relationship, so it's none because they don't even share a transversal. 17 and 7, okay, D is the line that they share. Those are alternate interior. 13 and 15, no transversal, so none for the transversal, but they are vertical angles. 20 and 19 are, there's no transversal, but they are a linear pair. 9 and 15, there's your transversal, so that's going to be C, and they are alternate exterior. 6 6 and 13. Transversal is C, and they are corresponding. So, okay. Sorry guys for the interruption. All right, next one, a little bit more interesting. Okay. So the next one here. I know that these lines are parallel. I know if this is 38 degrees, then this angle also must be 38 degrees because those are corresponding on my lines. This also must be 38 degrees. I know if this angle is 76, then this angle right here has to be 76 degrees. I know that the three angles on a straight line will add to 180, these three angles. So I know 38 plus 76 plus the measure of angle Q, I guess, is equal to 180. So that's going to be 114 plus the measure of angle Q is equal to 180. So the measure of angle Q is equal to 66 degrees. Okay. Next one. If F is parallel to G, this is something that's really important for your test. You know that consecutive interior angles are going to be supplementary. So I know 5x plus 9x plus 26 is equal to 180. First, this is going to be 14x plus 26 is equal to 180. 14x is equal to 154. And then we divide by 14, divide by 14. If you don't know how to do long division, you guys should know. So 14 goes into 154, 14 goes into 15 once, minus 14, bring down the 4, 14 goes into 14 once, minus 14, 1 times 14 is 14, and that is 0. So x in this case is 11. For my next one here, if I know that these angles are parallel, I know if this angle is 130, then, or the lines are parallel, then I know this one also has to be 130. I know that these two angles are consecutive interior, so they add to 180, so the measure of angle P plus 130 is equal to 180. So subtract 130 from each side, so the measure of angle P is equal to 50 degrees. Number 11, I focus on my parallel lines here, and then this right here. I know if this angle is 74, then this angle right here has to be 74 because they are corresponding. So I know x minus 3 is equal to 74, so x is equal to 77. The other thing I know that could be helpful, I know that this angle is 41, so this angle is 41, because those are also alternate interior. And I know another thing. I know since this angle is 74, I know that these three angles add to 180. So I know 74 plus 41 plus y plus 8 is equal to 180. So y plus 8 is equal, or y plus 8. Combine my like terms. Y plus 123 is equal to 180, so y is equal to 57. And so that's your answer for that one. This next one, there's a whole bunch of different ways to do this one. I know if this is 118, then this angle here, we know that these lines are parallel. I know that this angle right here must be 180 minus 118. So this is going to be 62 degrees. I also know something like, I also know if this angle is 118, then this angle also has to be 118 because they're alternate interior. So you could use that, and you could find this by doing, if this is 180, or 118, sorry, minus 90, okay. Another way to look at it is, I know that the three angles in a triangle add to 180, so I know I can find this angle right here, which is going to be 180 minus 90 minus 62, which is 28 degrees, which means that this angle right here is also 28 degrees, and 118 minus 90 is also 28 degrees. So that's the measure of angle. The measure angle ABD is equal to 28 degrees. Next one. First thing I do is I split this into two problems. I know if this angle right here is 28 and these lines are parallel, because it's an auxiliary line, this is also 28 degrees. Knowing that, I also know that this is going to be 56 minus 28, which is 28 degrees. If I know this is 28 degrees, then I know this angle X right here is also 28 degrees. So that was that one. For this one, I know that these lines are parallel. I also know that this angle and this angle must be congruent because they're corresponding. So 5x plus 20 is equal to 70. So 5x is equal to 50. X is equal to 10. Okay, this next one, super interesting. So it's kind of like the other one where I had to break this down. So I know, since these lines are parallel, that 2x minus y plus 60 is equal to 180. So I'm going to subtract 60, I'm going to put this in standard form. 2x minus y is equal to 120. I also know from these two angles that 2x plus y plus 40 is also equal to 180. So I also know 2x plus y is equal to 140 degrees. Now we have a system of linear equations. My first equation is 2x minus y is equal to 120. And I also know 2x plus y is equal to 140. So this is just a little algebra review question. 120 plus 140 is going to be 260. Negative y plus y is 0, which is good because we can't solve this in two variables. 2x plus 2x is 4x. So I take everything and I divide by 4. X is equal to. And I'll do my long division over here. So I have 260 divided by 4. 4 goes into 26 6 times. 6 times 4 is 24. 2, bring down the 0. 4 goes into 25 times. So I know x is equal to 65. If I know x is equal to 65, and I know 2x minus y plus 60 is equal to 180, I know that 2 times 65 minus y plus 60 is equal to 180. 130 minus y plus 60 is equal to 180. 190 is equal to 180. Negative y is equal to negative 10. Y is equal to 10. So that was a super tough problem. The idea is there. You need to make sure the consecutive angles are supplementary, but I did not put one that was that difficult on this test. So which lines are parallel if the measure of angle 1 plus the measure of angle 2 is 180? So these are consecutive interior angles, so it would have to be J and K. And it ends up being A. So converse of consecutive interior angles theorem. Number 17. It says which lines are parallel from the given information, state the postulate or theorem. So it says angle 3 and angle 6. Well, those are alternate interior. So it's R is parallel to S. Whenever we prove parallel, it's going to be the converse of alternate interior angles theorem. Okay. The next one, number 7, is I know angle 1 is congruent to angle 7. So I know L is parallel to M, and that's going to be the converse of corresponding angles postulate. So that's that. Okay. Number 8, so that was that one. Number 18, find the value of x for which P is parallel to Q if the measure of angle 1 is 4x and the measure of angle 3 is 112. So if P was parallel to Q, then 4x would be equal to 112. Divide by 4, x is equal to, 4 goes into 112, 4 goes into 11 twice, minus 8. 11 minus 8 is 3, 4 goes into 32, 8 times, minus 32 is 0. And so x is equal to 28. This last one should look quite familiar. If this is 67 degrees, this one right here would have to be 67 for those to be parallel. But we can't write that. What we need to do is only thing we can do for this is we can find linear pairs because we don't know if they're parallel. So for this angle here, I know that this angle is going to be 180 minus 67. So this whole angle is 113, which looks very familiar to this right here. Now, I also know that this angle right here is going to be 180 minus 113, which is also 67 degrees. Now, if you notice, these are alternate interior angles. And I know if alternate interior angles are congruent, lines are parallel. So bare minimum, line PN must be parallel to line QR by the converse of alternate interior angles theorem. Now, down here, we really don't have any information. I mean, I could say that this angle here is 115, but that doesn't quite help me. So I'm actually done. Those are the only ones that I could say were parallel. Okay, this is find the value of x if P was parallel to Q. So if P was parallel to Q, I know that those two angles would be equal to each other. So I know 2x plus 2 would be equal to x plus 56. So I know x would have to be 54. So that's one thing. All right. So then the next thing is, well, it says find y if r was parallel to s. So if r was parallel to s, those are consecutive exterior angles. So I know y plus 7 plus 3y minus 17 is equal to 180. So it's going to be 4y minus 10 is equal to 180. 4y is equal to 190. 4 goes into 190, 4 goes into 19, 4 times, minus 16, 30, 4 goes into 30, 7 times, minus 28, so we have 2 remainder, so it's going to be 47 into force, which is 47.5, so Now, it asks, can R be parallel to S and S be parallel to Q at the same time? So what we do is we substitute, okay? When I plug in, I know that if those lines are parallel, X would have to be 54. So for this right here, this angle here would have to be 2 times 54 plus 2. So that's going to be 110 degrees, okay? And the same thing here. This one would be 110 degrees if those were parallel. Now, if I put 47.5 in for the other one, so that's going to be 3 times 47.5 minus 17. So that's 142.5 minus 17. Which is 125.5. So the measure of this angle is 125.5 degrees. Now, if R was parallel to S, these two angles would be congruent, and they're not congruent. We have another issue. So if I put in, this is 47.5 plus 7, so this would be 54.5. These two angles here, and here, don't add to 180. So I know that 110 plus 54.5 does not equal 180, because it's going to be 164.5, does not equal 180. Also, so this is a big no. Also, I know that 110 is not equal to 125.5. So that's that. Number 21, use a diagram and what is given to write a two-column proof. So this isn't too bad. So we have our statement, and then we have our reason. I know L is parallel to M. That's given. I know angle 1 is congruent to angle 2. That is also given. Okay. Now I'm trying to prove that A is parallel to B. If I look at A and B, there are only two angles on A and B. We have my angle 2 and an angle 3. Those are alternate interior. So my goal is to prove that angle 2 is congruent to angle 3. If I can prove that, then I can say A is parallel to B because of alternate or converse of, good Lord. Converse of alternate interior angles theorem. Okay, so I kind of know the last part of my proof because I know if I can prove that those are congruent. So now I have to figure out how I can prove that. Well, I am given that L is parallel to M. If L is parallel to M, then I know angle 1 has to be congruent to angle 3 because I know if corresponding angles are congruent, or if lines are parallel, then corresponding angles are congruent. So that's just going to be, in this case, is just going to be corresponding angles postulate. No converse. You only do the converse if it's parallel. So I know 1 is congruent to 2, 1 is congruent to 3. So how do I know 2 is congruent to 3? Because I can replace the angle 1 right here with angle 2. And so that's going to be good old substitution. And so that's our entire proof. So substitution, converse of alternate interior angles theorem. All right, last page or so. Okay, what's the slope of the line that passes? Remember that slope is change in y. So change in y, it's going to be 5 minus 3 over 2 minus 7. 5 minus 3 is 2. 2 minus 7 is negative 5. And so that's the slope. What's the slope of the line shown? You have to go up 4 and over 3. So that's going to be 4 over 3. Find the equation of line and slope-intercept form that passes through these points. Okay, so it says in slope-intercept form, so we make a note of that. First thing I have to do is I have to find the slope. So that's going to be 7 minus 3 over negative 3 minus 3. 7 minus 3 is 4. Negative 3 minus 3 is negative 6. And I simplify. That's going to be negative 2 over 3. So I have the slope of my line, I'm missing the y-intercept. So to find the y-intercept, well, I know y equals mx plus b. I know that the slope of my line is 2/3. I know when I plug in -3 for x, I get 7 for y. So this is going to be 7 is equal to -6/3, because numerator times numerator, denominator times denominator. 7 is equal to -2 plus b. Add 2 to each side. B is equal to 9. So the equation in slope-intercept form is going to be y is equal to 2/3 x plus 9. What's the equation of the line in point slope form of the line that passes through this? And so we're looking for a point slope form. Well, the only two things I need for a point slope form are a point, which I have here, and the slope, but it's perpendicular, so instead of -1/2, or instead of 1/2, it's going to be -2/1 or -2. And so this is actually pretty easy. It's going to be y minus the y value is equal to my slope times x minus my x value. So it's going to be x minus -2, so it's going to be x plus 2. So there's my answer there. This one, I don't know why I put a graph there. It's a standard form, write an equation of line that passes through point P is parallel to the equation of the line given. So first off, I take my standard form and I find the slope. The slope of the line is -1. So I know the one I'm trying to find also has the slope of -1. I know y equals mx plus b. I know the slope is -1. I know when I plug -2 in for x, I get -2 for y. -2 is equal to 2 plus b. I subtract 2. B is equal to -4. So I know y equals mx plus b. So I know that an equation is going to be y is equal to -x minus 4. If we're putting it in standard form, we should have if we had fractions, we'd have to get rid of them. I don't have fractions, so I don't have to. So this is going to be x plus y is equal to -4. There's my standard form. My equation is going to be, so this is -4, and then my slope is -1. So if I wanted to graph this, make sure you have arrows for your graph. Or the equation of line shown, super simple. Slope is up 1/4, and my y-intercept is -2. So that's going to be y is equal to 1/4 x minus 2. Next one, slope-intercept form. It's perpendicular to this line, so it's 3x minus 4y is equal to 9. Subtract 3x, subtract 3x. -4y is equal to -3x plus 9. Divide by -4, divide by -4, divide by -4. Y is equal to 3/4 x plus 9 over -4. So the line that I'm trying to find, slope is 3/4. Slope of the line that I'm trying to find is going to be -4/3. I know y equals mx plus b. So I know -5 is going to be -4/3 times x plus b. -5 is equal to 16/3 plus b. I subtract 16/3 from each side. I know this is 5/1. I want it over 3, so I'm going to multiply by 3. So it's -15/3. -15/3 plus -16/3 is going to be -31/3. is equal to b. So my equation is going to be y is equal to 3/4 x minus 31/3. All right, are the lines parallel, perpendicular, or neither? For this here, okay, I'm going to put this in slope-intercept form. So I'm going to subtract 1. This is 3y is equal to 6x plus 3, divide by 3, divide by 3, divide by 3. Y is equal to 2x plus 1. Slope of this one is 2. 2y plus 1 is equal to x minus 9. Subtract 1. 2y is equal to x minus 10. Divide by 2. Y is equal to 1/2 x minus 5. And so they are not opposite signs, so this one's going to be neither. This next one, it says two lines are represented by the equations. Find the value of m that would make these lines parallel. So we have our negative 1/2. Oh, that's not what we have. We have negative 1/2 y is equal to 6x plus 10. I want to find the slope of this line right here, so I'm going to put it in slope-intercept form. So I multiply by negative 2/1. And so I end up with y is equal to negative 12x plus 20. The slope of this line is 12. So what would m be to make those parallel? Have the same slope of 12. And not last but not least, the coordinates of quadrilateral PQRS are P is negative 2, 2, 4, 6. So that's P. Q is 4, 0. R is 1, negative 4. And S is negative 5. Positive 2. Okay, and it says determine if the diagonals of PQRS are perpendicular. Explain your reasoning. So we're looking at this right here and this right here. Well, we can do slope algebraically, or we can go this way. So this is down 2, 2, 3, 4, 5, 6. Oh wait, no, diagonal. Yeah. 2, 4, 6, 8, 9. So the slope of this perpendicular right here is negative 2/9. And then this diagonal here, I go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I go down 10 into the right 3. And so the slope of my other line, the slope of 1 is negative 2/9. The other line is going to be negative 10/3. And so these are not perpendicular because negative 2/9 times negative 10/3 does not equal negative 1, which is one of the reasons. So that's about it for the review.